case it fails.
Recording in progress.
Well, welcome back, everyone. We're going to start this evening off with a little bit of a challenge for you. We learned how to do the mean yet on Tuesday. So, to get you started, calculate the mean for Group A is going to have 5 numbers. And Group B is also going to have 5 numbers. So calculate the mean for each of those groups. In this section, we're doing sections 3.2 and 3.3. These are on other measures of central tendency. Today is dispersion / deviation. And weighted means would be 3.3. For those of you watching on on YouTube, it's fall of 2022. This is Math 21, Introduction to Statistics at College of the Sequoias. As a reminder, to calculate the mean, you add up all the numbers. And then after you're done, you could hit enter or you can use parentheses, divide by the total number in the group. That's correct, Emmanuel. Let's see if other people get it, what they get. Anybody else doing it? How many people we got here? Give you one more minute and we'll do it together. You don't have to do it by hand. You can use a calculator if you'd like. That's good, Isabella. That's A. Let's see some more answers. What else we get? Something happened on B, Isabella. You might have hit divide by 5 before you hit enter. And I know from Malayo you did. So, I wanted you to try this because I wanted you to see what goes wrong if you do it the wrong way or follow the incorrect route. So, I'm going to do it the way yes, Caprice, that's it. That's correct, Isabella. The common mistake would be to just type them as is. And then hit divide by 5. Oops. Without changing anything. And you would get 206.8. But we really have to do all of these on top first. So if I do them all on top first, I get 250, and then I divide by 5, and I get 50. If I do the same thing with the second group, 10 and 90 add up to 100. 30 and 70 add up to another 100. That's 200. Plus 50 is 250. 250 divided by 5 is 50. So this is kind of a great learning opportunity because Famalayo had 206.8 and 178. I want you guys to see that. Like if you've done it without doing the hitting enter first or using parentheses, some calculators have this parenthesis key button. 10 plus 30 plus 50 plus 70 plus 90 and the parentheses divided by 5, you get 50. So if you get a number like 206.8 or 178, I want you to take one look at something. The mean is the average value, and I can look right away at them and see that 206.8 is larger than any value in A, and 178 is larger than any value in B. There's no way it can be the mean. So it will give you a red flag if you're looking for it and you know what mean means. It means it's the average, and so the average should be somewhere near the middle. It definitely can't be larger than the largest value. It's a great way to, like, did I make a mistake? Yes, I made a mistake. I used little things like that all the time when I'm doing math. I try to do a lot of math quickly in my head, and if I come up with something that's unreasonable, I know I screwed something up. We also showed you how to do this in StatCrunch. I wanted to remind you. We can do stats, summary stats, columns. I can select both values, and I'll just click on mean for now. Okay. So I got 50 for both. Does that seem like a useful tool? If I look at these two groups, does 50 tell me really a whole lot? It tells me some. It gives me the average, but look at these values. The lowest one in A is 46, and the highest one is 54. They're both really close to 50. Whereas in group B, I've got 10 and 90, which are a long ways away from 50. So, but they both have an average of 50. A mean of 50. So the mean doesn't give us the whole picture. It doesn't paint the whole picture. Because these numbers, group A is close to the average or to the mean for all values. But group B has a lot of swing in it. A lot of difference. So this is where we discuss dispersion. Dispersion is how much the data is spread out from the mean. One of the simplest measures of dispersion is the range. Range. It's the simplest to do. What we do is we take the largest value and you subtract the smallest. So for group A, I have 54 minus 46 is 8. And for group B, I've got 90 minus 10 is 80. And we talked about outliers and things being resistant before. Let's say we have that A again. So is range resistant to outliers? Let's check. Let's use a let's change A. Let's add one more value to A. Let's make A. I'm going to put them in order: 46, 48, 50, 52, 54. And let's add one new value. Let's add 100. Now when I do largest minus smallest, it's going to be 100 minus 46 is 54. So the 100 is an outlier. It's nowhere near 46 to 54. And it drastically changed the range. The range went from 8 to 54. The range is not resistant to outliers. At the end of that page, and we can do that over here in StatCrunch. We can go stats, summary stats, columns. I can select variable 1 and variable 2. I can scroll down, click range, and click compute. It will give me the values there. Any questions so far?
Can I see how you found the mean on StatCrunch?
Yeah. It's the same way I just did the range. We're going to go stats, summary stats, and then columns. For each column you want to find the mean for, click it here. You can click on the first one and drag down, and it will select everyone between. You can also do hold down Control and click, and that way you can skip numbers. But I only have 2 columns, so it's a little hard to show. Oh, I know how to show it. So stats, summary stats, columns. My two values were, the columns we're looking at are variable 1 and variable 5. I can click on variable 1, hold down the control key on a PC or laptop. On Apple, it's command. Someone answered this last week. And then when you're holding it down, click on the other thing that you want. Once you've done that, we have a list of statistics that we can choose from. Many of them are highlighted already, but I think doing that sometimes gives you information overload. We can do that control clicking here. I can do mean and range and do them on the same screen. Okay. So another measure of dispersion that we really like is called standard.
Do you mind if you put the page back really quick so I could take a picture of it?
Yep.
So I could pop it down.
I don't know if
Okay,
you need the
thank
top
you.
or the bottom.
Right there. That's good.
All good?
Yes.
Okay. So the next one we're going to talk about is called standard deviation. Sometimes people just say deviation. That pen's dying. Let me throw it away. And we use this a lot for bell-shaped data sets. And this is going to be our most common go-to for the most of the semester, to be honest. We're going to use mean and standard deviation more than you can possibly imagine, especially after the midterm. We'll use it some before the midterm, but we're going to use it a lot after the midterm. And it's different between populations and between samples. So the population standard deviation you will see me abbreviate it as that. You might see me say that using 3 letters. The symbol we use for the populations version is sigma, the lowercase one. And it's got a shitty formula. And if you do this by hand, you deserve to agonize over it. So what you do is you find the mean, and then for each mean, you calculate the different. You take the value and subtract it. So in Stacker, I'll walk you through how it's doing it here. Clear up some table space. So I start here. We already know the mean for the first group is 50. So then I do for each row, I take the number in the row and I subtract the mean. 48 minus 50 is negative 2. 46 minus 50 is negative 4. 50 minus 50 is 0. 52 minus 50 is 2. And 54 minus 50 is 4. That was doing this part right here. Xi minus mu. Then we have to square each of these values right here. So negative 2 times negative 2 is 4. The negatives cancel. Negative 4 times negative 4 is positive. Negative 4 times negative 4 is positive 16. 0 squared. That's what the square means. Time multiplied by itself is 0. 2 squared is 2 times 2 is 4. And 4 squared is 4 times 4, which is 16. I use dots because then we use x's for a lot of things as variables. So I use dots to do multiplication. I'm going to just type what I had here. Then what you do is you add them all up. Okay, so what we just did there is we did the square part. We add them all up. If I add them all up, I get 4 plus 16 is 20. And I have another 4 plus 16 down here is another 20. Those add up to 40. So right now, my sigma looks like this. Square root of 40 over n. N is the sample size or population size. Here it's 5. 40 divided by 5 is 8. And square root of 8 is close to 3. .828. That's how the population one is done. It's not so bad when you only have a few of them, like this set had. There was only 5 numbers. But you could see how this could get pretty tedious if there's like 100. The sample deviation, standard deviation, is very similar. We use S for it. And it looks very much the same. We got a summation symbol. I have an xi minus the mean in sample is x bar, whereas the mean in population is mu. Mean in sample is x bar. We're going to take those, we're going to square them, we're going to add them all up. We're going to divide by the sample size, but we make an adjustment. We are doing n minus 1. And then we take the square root. So whereas StatCrunch could do, and this would be the same thing. We'd have, but instead at the end, what we get down to, let me box that. That's the formula. Note, remember the mean added up. Everything should have added up. Oh, no, that's not true. Yeah, if I do the same thing with the same group, treat it as a sample rather than as a population. The only difference here would be S equals square root of 40 divided by 5 minus 1, which is n minus 1. 5 minus 1 is 4. 40 divided by 4 is 10. So S equals the square root of 10, which is a little bit above 3. We had used in StatCrunch, we used the same thing for mean. We can't use the same thing for standard deviation if it's, we really need to know if it's a population or a sample. So the important thing to know for StatCrunch, the one that says standard deviation, let me load it up, show you real quick. Stats, summary stats, columns. We're going to do column 1. That one right there is for samples. It says std.dev. This is for samples. The one for population is unadjusted standard dev. Nope. Not answering you. You look like spam. Unadjusted standard deviation. This is for populations. Most of the time, we are using this top one. Almost 99% of the time in this class, we're going to be using this top one. But there is two different ones, one for samples, one for populations. And let's see if we get the same values I got. 3.162 for sample standard deviation. I got that right here. And 2.828 for if it's a population. Notice they may not seem very different, but they're off by 0.3, like 3.1, or almost 3.2. This is about 0.35 larger than this one, which is about 10% larger in this case. That's enough to be wrong. Okay. So pay attention for this. Another name for this n-1 that we have right here, n-1 is called the degrees of freedom. You will see the abbreviation D.F in the homework. They are talking about degrees of freedom. You have to take the sample size and subtract 1. Okay? Leave that up for another minute. So if you want to take a picture, now's the time to snap a shot.
What does the UNADJ stand for?
Unadjusted.
Unadjusted. Okay.
Unadjusted. And what they mean by this has just n. This n has been adjusted to go down by 1. So this is the unadjusted sample size. This is the adjusted sample size. The idea of it is when you're working with the statistics, let me pull out another. Oh, this marker will work. Like 5 numbers, I've got 5 pins here. And I could ask, oh, well, let's do it. Who do I got in class right now? Caprice, pick out one of those pins. Which one should I take out of the group?
The green.
This green?
Yeah.
Okay. Paige, you have 4 pins to choose from. Which pin should I take out of the group from your perspective?
The blue.
The blue? Okay. Isabella, your choice now. You got 3 choices. Blue and green are off the table. Someone else already chose them. You want black, red, or, I don't know, puke green? What is that? That's an ugly green.
Green.
Green? All right, Emmanuel. You get black or red. Not a lot of options left for you. Which one?
Red.
You want red? Okay. And Famalayo, I was going down in the order that's listed on Zoom. I might have to take this. Give me 1 second. Hello? Hello? Rude. They didn't even talk. Yeah, from Malao. Did you get from Malao? Send me a message. You chose. I don't even know if it's a he or she. I can't tell by the name. From Malao chose black. But did you really get to choose? Did you have any choices? Was there any option? Were you free to make a choice? No, you weren't given any choice. That's the idea of degrees of freedom in a nutshell. When the standard deviation has to meet certain things, and if you pick 4 out, I'm going to use those one right there. Whatever is left has to be a specific value to make it work. That's and the last one doesn't have a choice. That's the easiest way I can say it without going into the whole bullshit of why it's that way. You'll just, to be honest, you don't care. I don't care. I care so little about it, I don't remember it. I have to look it up if you really wanted to know. But the last one that had no freedom to make a choice, degrees of freedom. That's the way I remember it. Okay, so next thing. We have one more thing that we like to use on the table. And I will add them both right now. Standard deviation goes with variance. Unadjusted standard deviation goes with unadjusted variance. I'm going to bring that back up, actually. So variance and unadjusted variance. Do I have 10 and 8 anywhere on my screen?
Yeah.
I do, right? I got it right here. There's my 10. There's my 8. 3.162 was before we took the square root of 10. Going the other direction, instead of taking the square root of 10, I can square 3.162 and I get 10. This was S. This is S squared. So variance is the square of standard deviation. It's the same for both groups. So S squared, this is for samples. And for population, we had sigma. Sigma squared will be for population. I don't know why they use 2 different ones. I mean, there's not a whole lot of difference. I mean, it's doing an extra math step along the way. It's not like they're calculating something different. They are literally the exact same calculation. So I don't know why they got hooked on doing it in mathematics. It's just the way it is. To do all of these calculations, let me put up the standard deviation formula for samples again. I need 2 things, really. Everything else can be calculated. xi represents the data set. So we need a data set, and that might seem like a no-brainer, but it's worth pointing out. You need values that have numbers in them. You can't calculate standard deviation of hair color unless we assign hair colors numerical values. These are numerical operations, so they take numbers. The other number we need is n. We need the group size. So those are the two things we need, and we need them for mean also. So I'm going to edit this to just show the standard deviation. No, let's put them back. I want the standard deviations together, and then I want the variances together. Maybe I'll separate that by n. I'll put something small in there. Variance and unadjusted variance. Okay, well, let's check if these are resistant to outliers. We talked about this for range. Are these resistant to outliers? One way to check, add an outlier and then recalculate. I don't know. Let's do more than 100. Let's go 1,000. Make a real outlier. Stats, summary stats, columns, and I'll pick them in the same order. Standard deviation, unadjusted standard deviation. Is that how I did it before? Yep. Then I said n, and then variance, and then unadjusted variance. Click compute. So before and after. Notice how much it's changed. Standard deviation went from 3 to almost 400. Same thing with unadjusted. Went to, well, 350 here, but it went from below 3. Variance is the same issue. We went from 10 to 150,000. Good God, that's a big difference. It's a big difference. So, no. Not resistant to outliers. And if you don't remember how, if there's a question like this on the midterm or anything like that, you can see what I did to check. If I don't remember, I can always make a set of numbers, pick a set of numbers. If I wanted to be lazy, I could just do 1, 2, 3, or 1, 2, 3, 1, 2, 3. Calculate all those things that we were talking about. Variable 4, we're looking at the mean, mean, variance, standard deviation. And then I could go ahead and add another number and recalculate it. Oh, and range. And then I could recalculate. Oh, that was the adjusted one. Let me get rid of the 100 and redo it here. So before I added the 100, the range was 2. Variance is 0.8. Standard deviation is 0.89. All of these were hit pretty hard. The median was not. And I'll have to add the 100 back in to redo this one. Why didn't it do it? Now I'll re-add mean here, or median. Median didn't change, so the median's resistant, the other ones are not. Or not. But those are the ones we've learned so far. There is another equation that these are all this standard deviation is used for bell-shaped data. If the data is not bell-shaped, they use, and I love the name. I'm going to write it first so you can see how it's spelled. Chebyshev. Chebyshev's inequality. What they do is for k deviations, where k is greater than 1, what they do is they take k, they square k, they put it in this formula. 1 minus 1 over k squared times 100% is captured within k deviations. So, and well, I'll see if we have any problems like that. I don't think we do. There's definitely not one on the midterm like that. U minus k times the standard deviation, not u, mu, is less than that percentage and would be greater than that percentage. I know that may not make sense right now. Hopefully, I don't think we have Chebyshev. What do I mean by captured within k deviations? Let me show you the standard bell curve graph. And this is one you should memorize. And I will show it repeatedly. But if you don't know it for the midterm, you're kind of in trouble. Damn, that looks like a good hill, doesn't it? So in the center, we have our mean, or X bar, sample or population. And then we're going to put 3 marks in either direction. The first mark goes where the hill's like kind of like, almost halfway gone. And it should be the same distance each direction. This is mu plus sigma. This is mu minus sigma. Remember, mu is mean, and sigma is standard deviation. These are both numbers. So here, what I'm doing to go from here to here, I'm adding 1 standard deviation value to the mean. in the terms of the last thing we had 50 for our thing. And what was the standard deviation I had for samples? I had 3.16. So 53.16. I'll do it right down here. Plus 3.16. And then doing it this way is minus the 3.16. So 50 minus 3.16 is 46.84, I think. I'm doing that without a calculator, so I could be wrong. Then we go a little further where the hill has still got some stuff left, but not a whole lot. It should be the same distance. And we do that distance out 2 more times. If I have more room on, oh, this should be a little bit further, not there. Each time we are adding 1 deviation. Going to the right and subtracting 1 deviation as we go to the left. So this is mu plus 2 times sigma, and this is mu plus 3 sigma. And I can find the values that we had on there. So 53.16 plus 3.16, 56.32 plus 3.16, 59.48. I could do it going downhill. Okay, so why did I give you that information? Well, I'm going to put little dotted lines to show you kind of what's going on. So for all standard bell curves, not for all bell curves, standard implies mean of 0, standard deviation of 1. That's the standard part. If you just have a regular bell curve, you have a mean and standard deviation. This stuff still applies. We track things deviations away. And then we know from bell curve how much each area this represents. This area right here is 34% of all the data values. And this is like a mirror image. So this side right here is also 34%. The next group over also looks the same. These values are 13.5%. The third group is 2.35%. And outside of that, everything greater than 3 standard deviation is just 0.15%. And the same thing with less than 3 deviations, 0.15%. what this means is we've calculated the mean. Oh, maybe I could. Look for my data. Let me go pull a data set. Let's find a group that has a shoe size is probably good. Let's do the histogram on shoe size. Oh, it doesn't want to let me. Why? Oh, shoe. It's called shoe. This is roughly the shape of a bell. Okay? And if I want to go, let's see, what are the summary stats for this group? So shoe size, I want mean and standard deviation, variance. Why not throw in median and range? So the mean shoe size is 9, the standard deviation is 2. At least in my data set. And I am rounding to whole numbers here because that's how I roll. The mean is 9. The standard deviation is 2. Which means if I do +1 standard deviation and -1 standard deviation, 9 plus 2 is 11. 9 minus 2 is 7. Shoe sizes 7 to 11 represent 64% or 68% of the group, of the sample. For n being 213, let's see, 68 is about 140. 68% of 213 is around 140. So 140 of the people that entered their shoe sizes is between this mark and this mark. 68% lies there. And I got that from adding the 234s. So the three big numbers to remember, you'll want to know all these numbers, but the ones that you'll see on graphs the most is when we go within 1 deviation, minus sigma plus sigma. I need a new piece of paper. I'm not gonna have enough room for this. Actually, let me let you finish looking at this, and I'll use that same graph without redrawing it. I'll just use another piece of paper. Anyone need it up longer? Okay. I've got my graph there. I'm going to write it right here. So between here and here, 34% plus 34% is 68%. 68% of the data is within 1 deviation of the mean. If I go out 2 deviations, this represents 95% of the data. And if I go out to 3, 99.7% is within 3. This is called, this data breakdown that I did on the graph here and here is called the empirical rule. And you will see problems where they'll do something like this on the test. So example. Actually, let me give you, we'll do it here. I'll use the shoe size one. So shoe size mean was 9. And well, this is not a population. This is a sample. And S is 2. They might ask you what percentage is between 5 and 11 in shoe size. So the way I'm going to show you, I'm pulling, this graph I had up here, I'm going to rewrite some of the numbers down below without the whole graph. We got mu in the middle. I go 3 this way, 3 this way. Minus mu minus 1 sigma, mu minus 2 sigma, or x bar and x bar minus s if you're doing samples. I'm so used to writing the population version that I'm going to use it. Mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. The percentages are, I'm going to just write them down, 34. This is taking that whole table and making it look flat. 13.5 is the next group. 2.35 is the next group after that. And there is 0.15 on each of the ends. So how does this apply to the question they gave me? My mean, or my shoe size mean, is right here. It's a 9. And I'm just going to, if I know the values, I'm just going to fill in the table because they usually ask more than one question. I'll just keep adding 2 to it until I get to the end. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. And then I can subtract 2 going the other direction. 9 minus 2 is 7. 7 minus 2 is 5. And 5 minus 2 is 3. So when they say what percent is between 5 and 11, what I need to do is come here and look where my 5 and 11 are. And use those percentages between them. This is 81.5 when we add it all up. They might say something like, what about 7 and 15? Well, 7's here and 15's here. I don't want to include that 0.15. It's in the last group. So here I'm adding up 34% plus 34% plus 13.5% plus 2.35%, which looks like it's only 2.35% larger than this. That should be 83.85%. They might ask you questions like that. And I am going to take this data and I am going to sort it by shoe size. I'm going to sort all columns by shoe size column. And now let's take a look at the 7 to 11 first. I want to see where shoe size starts at 7 right here. And I want to see where it ends at 11. Oh. Okay, so it's down to 184. Can I scroll and highlight them all while I'm doing it? Please let me do this. Tedious, but it won't take me too long. I'm trying to illustrate an example here. Oh my gosh. Looking for all this. Let's do 7 to 9. I'm getting tired already. So we're going to go from 7 to 9. That might not work. I know it's not going to. I need to go the whole way. It'd work if I didn't include one of the data groups, but I already did. So if I do 7 up to 11, starting at 7, go up to 11, but not include 11, I have captured the 151 rows. Shows me right here, the 151. And there was 213. What is 151 divided by 213? 0.70. 7089. What if I go ahead and add in all the 11s? Maybe this isn't bell curved enough. 161. So 7 to 11, including both of them, is 161 over 213. Is 0.7558. Maybe this isn't a bell-shaped graph. It's not close enough. This should have 7 to 11 should be 34 and 34 is 68%. Well, no, that's right. That's here. 7 to 11 is one deviation like that. 34 and 34 is 68%. That's close to 68%. It's 70-ish. if I go up to size 13, seven to 13 would be 34, 34, and 13.5. Should be like 81.5%. 177 out of 213 is 83%. So if it's a dead ringer for a bell shape, these percentages are really close. Well, if it's an exact bell shape, these percentages are exact. If it's close to an exact bell shape, these values are close. I got 70 rather than 68, and I got 83 rather than 81.5. But that's what this is. This empirical rule is designed to approximate the values without calculating. You see how long it took me to do that? Clicking all the rows that counted, how many rows counted. It's a pain in the butt. So the empirical table, this table right here, is designed to help you quickly estimate the values. And if it's an actual perfect bell shape, it's going to be spot on. I will write the values, the ranges again, right? Oh, maybe I'll put this all on one screen. For those of you that want to take a picture, can I get it all on one screen? I guess you don't need the top of the graph. There we go. 68%, 95%, 99.7%. In this class, you are going to be asked repeatedly if something is unusual. Something unusual happens less than 5% of the time. So on the bell curve table, what it really means is outside of 2 deviations. Because over here, I've got 2.5%. When I add up 2.35 and 0.15, I get 2.5. And over here, I have 2.5 when I add up 2.35 and 0.15. 2.5 and 2.5 add up to 5%. That's considered unusual data. Whoa. We got more to do in chapter 3. I do want to show you the weighted mean before we wrap up. And I will, once again, I will show you this graph repeatedly. I think I even have a clean version in Canvas. In the file section, let me go look. Oh, shit. This is definitely helpful for you. It'll be in the stats formula table. In Canvas, if you go into Files, over here on the left, and you click on Useful Handouts, and you click on Stats. StatCrunch Tech Help Guide. 12 pages, not long. You could print it out and keep it on hand. It shows what to do instead. It gives you directions how to do stuff in StatCrunch based on the section. We just did 3.2, so, and 3.1 was last week. It showed do stats, summary stats, and columns. Oh, and 3.2 it says to do the same damn thing. 3.3, this is the weighted mean kind of thing. We're not going to do it much in class, but I am going to show you how it works because it's something you're quite familiar with. On Tuesday next week, we're doing measures of position and outlier. and the 5-number summary box plots. So it will tell you how to do this stuff. That's worth knowing or having available to you or knowing about. The other one, stats, formulas, and tables. If it's not the first thing on here, I'd be surprised. It's not. It's not the first thing. Where is my bell curve on here? Oh my gosh, they don't have the empirical rule bell form. Wow. Fail. If you Google empirical rule statistics, click on images, you can see all sorts of them. Oh, I don't like that one. The dark screen doesn't work well. So you can see printed out versions of them. These are only to 1 decimal place. I don't know if I like that. This is 2 point. Yeah, that's a bad one. Let's see. Do you go? That's a good one. It's got all the values it shows you. But the point is, you can Google empirical rule, and get a table where you could print out the table and have it available also. You should try to memorize the numbers though. Is that one any good? No, that only shows a little bit. Let's take a look at weighted mean. There shouldn't be any problems for you on it. But I think it's important that you know, because one of the most important things in your life as a student is your weighted mean. In terms of a student, this would be GPA. Your GPA is calculated based on a weighted mean. So what I mean by that is an A is worth 4.0, A minus is 3.7, B plus is 3.4, B is 3, B minus is 2.7, C plus is 2.4, C is just 2, C minus is 1.7. You know, I'm not allowed to give C minuses. I can give D's, but I can't give C minuses. It's not even an option in the grading scale. Some jackass in state government said you can't give a C minus because it's, if you're going to say it's satisfactory work with a C, just give them a C. Like we're hurting your feelings by C minus over a C. D plus is 1.4 and a D is a 1. So when you're calculating your grade, let's say you're taking stats. That's a 4-unit class. So this is Math 21. Let's say you're taking the support course. That's a 2-unit support for stats. That's 2 units. Let's say you're taking English 1. Is English 1 4 units also? And let me guess, is art, generally the elective ones are 3 units. I want a 3-unit one on this list, just to illustrate this a little bit better. So class search, art. Yeah, so you're taking art 1. And that's a 3-unit course. So if you got a 4-unit, a 2-unit, a 4-unit, and a 3-unit. Let's say that's your stuff. And let's say this is your first semester, so you don't have a GPA before this. You don't have a GPA before this. Let's say you get, what grade do you get? I'm going to say you get an A in math course because you guys have been working hard. You're showing up, you're asking questions, you're participating, you're probably going to do pretty good. But for some variation, I'm going to give you guys some different grades here. Let's say you have a C plus for art and a B here. Now, if I were just to take the mean of them as is and just pretend that's how it is, this would be a 4.0, this would be a 4.0, B is a 3.0, and C is plus is 2.4. 4 plus 4 plus 3 plus 2.4 equals 13.4, and if I divide by 4, I would get 3.35. This is not how you do it. Do GPA. We don't just take the average of the values. The weighted mean applies how much percentage of the group it is to the value. So you are taking 4, 2 is 6, another 4 is 10. You're taking 13 units. The 2-unit course does not have as much impact on your class as a 4-unit class. The 3-unit class has more impact than a 2 on your GPA, but not as much as a 4. So what they do is they take the number of units each class is, multiply by that. 2.4 times 3, I think it's 7.2, but I want to be accurate. So I'm going to do it on the screen. So 0.2. And we already said there was 13 units. Your GPA will be, I'm just adding up all those weighted values now. They've been weighted by the number of units. This is 43.2. And then we're going to do 43.2 divided by 13. 3.32. So it's close to the 3.35. That's just coincidence. I'll shift the grades around and show you what happens if a different class has the A and a different class has the C++. Ooh, that's a good way of doing it. So let's change the order now. I'm a clever guy. We still got the same classes. But let's say you like art and English and you get an A in these. And you thought the support material was fairly all right. You got a B plus there. But in stats, you're like, I don't like math. Math sucks. Oh, wait. I need to be consistent. I want to have the same grades. I had A, B, and C plus. So support, you got a B. Stats, you got a C plus. What would your GPA be here? So this is worth 2.4. This is 3.0. This is 4. And this is 4. Now, if I apply the unit values, number of units each class is, 2.4 times 4 is 9.6. 3.0 times 2 is 6. This is 16 and 12. Let me add all those. and I'm getting 43.6. Something's off. I guess I made the 3-unit class not. All I did is change it by 1. Let me make sure I got my values right. 2.4 times 4. Let me make sure I added them all up right. 43.6. And divided by 13 is 3.35. This was a bad example to do. I wanted to show you that doing math was important, and I came up with a higher GPA by focusing on your art rather than your math. Bad. I don't know. Something's wrong. Did I do something wrong up here? I did do something wrong up there. I can see it. Nope. No, I didn't. Huh. Point is, you get different GPAs. 3.35 here, 3.332 or 3.32 there. This is coincidence that it matches this. Coincidence. And that's what this is how they're doing it. Also, as you go on, every semester is like this. They will add new units with new grades applied to it. The grades that have a bigger unit value hit your GPA more than, oops, not there. The classes that have a bigger GP unit value have a bigger impact on your grade. That's probably a better way to do it. Let's do those again. Stats, support, English 1, and art 1. And I'm going to calculate 2 different groups. This is 4, 2, 4, and 3 units. In the first group, we're going to say you got A's in the 4-unit class, and you got C's in the other. And for the other group, I'll put the A's in the class with less units and C's in the ones with more units. So this is a 4.0, 2.0, 4.0, 2.0. We take each grade value, 4.0, we multiply by the units. Times 3. Art is a 3-unit course, 6.0. And I'm going to do this over here. This is 2.0, 4.0, 2.0, 4.0. This is times 4 times 2 times 4 times 2, which is, that makes them all 8. So getting A's in the 4-unit class, your great GPA would be 16 and 16 is 32, plus 10 is 42. 42 over 13. 8, 8, 8, and 8 is 32 over 13. What are these two values? 42 divided by 13 is approximately 3.2 GPA. 32 divided by 13 would give you approximately a 2.5 GPA. That shows the impact of what I was really trying to show a little bit more. The large unit courses have a bigger impact on your GPA. And this is how they calculate them. So if this is your first semester, or if you wanted to have some fun and go through your transcripts and calculate your GPA and see what See if your calculations match theirs. I don't know if that sounds like fun. I've never done that because it doesn't sound like fun to me. Might be to you though. You could calculate your GPA by hand. That's how they're doing it though. So the grade, these are called the weights over here. Because each grade is not worth an equal value. An A in up here, an A in English is worth more to your GPA than an A in art in the long run because it's got 4 units rather than 3 units. So they do weights times the data value, and then they take the mean of those. Again, it's not going to be on your midterm, but it is your GPA. I thought it would be good for you to know how it's calculated. And that's it. Oh, well, I guess I could show you the fancy formula they give you. They say x bar weight is the sum of weight I times xi, then divided by n. Or sorry, then divided by weight I. Which is what we did. We took weight 1, multiplied it by the first grade value, plus weight 2 times the second grade value. And the sum of the weights, these were weight 1 plus weight 2 plus weight 3 plus weight 4. This was my 4, 2, 4, and 3. That's where I got 13. So that's the formula they give you. I don't know that seeing a formula is helpful. But that's it for today. Unless you guys have any questions. We got one more day worth of chapter 3. We'll finish up chapter 3 on Tuesday. And we're right on track. Hope you guys are staying caught up with the homework. If you're in the support course, staying caught up on the support course work. It's all due by the end of the midterm, and you do not want to have to do the midterm and like all of those assignments that last week. That's just way too much math. You should be staying on top of it. And if that's it, that's all I've got for you guys.
I have a quick question.
Yeah.
Why is it that you use a bracket and then a parenthesis versus 2 parentheses?
So in math, when we use the bracket, I had bracket 7, I think 11.
Yes, it was 7-Eleven.
Okay, so what this means is include all values between 7 and 11. Also include 7, all values that are equal to 7. Do not include values equal to 11.
And then an example of those would be...
So in the shoe sizes, this was 7 up to 10.5.
Mm-hmm.
We don't
Okay.
actually include the 11s. This is kind of how they do it in the class size and stuff like that. When you're doing class size, the notes StatCrunch will. I don't know. Let's see how StatCrunch does it. Load. StatCrunch does it this way. See the bracket and the parentheses?
Yes.
This column I am highlighting right here includes 8s and 8.5s, but not 9s.
Okay.
Okay, but in my math lab, the way they would show this in my math lab, they won't show it like this. They will say, they'll show 7.0 on the left, and on the right, they might, or 7.00, and they might say 10.99 for the right value. A number that's really close to, but just less than 11.
Okay. Got it.
Some of the problems you will have seen, they'll say, okay, a class size of like 6,000, and they'll start you at 30. 30,000 and 6,000, or 30,000 is the start, 6,000 is the class width. Rather than just adding 30 or 6,000, getting 36,000, this is 35,999. They go to the whole number, and then the 36,000 is here.
Okay. And then the last class period. Did we have class on Tuesday?
We did.
Okay, and that went over 3.1, right?
3.1. And it should be on YouTube.
Today's was just on 3.2?
3.2
and a little
and
bit of
3.3. The
Okay.
weighted means is 3.3. And on next Tuesday, we're doing 3.4 and 3.5.
Okay.
3.4 is measures of position and outliers. We'll do the empirical rule again. And then we're going to do the 5-number summary and box plot for 3.5.
Okay. And then I had one more question. I'm still having like a difficult time using StatCrunch just because I feel like I don't know how to place the numbers like in the boxes like you do. Like versus having it in one row, which mine normally goes to. Yours goes into like multiple rows and organizes it by just like that. Like
Okay,
mine goes.
let me see if I can load a homework problem in. Give you some ideas. Like, you shouldn't hand type anything if you can avoid it.
Oh, for chapter 3, right?
Yeah.
Okay, got it.
So when you see this little picture right here, it's a window on top of a window. If you click it and do open in StatCrunch, it will load it in StatCrunch as a column.
Okay. Yeah.
Then it just takes practice. It really does. Everything we're doing so far has been stats and summary stats and columns. If you're doing it on the phone, are you doing it on the phone?
No, I'm doing it on the computer.
Okay, so computers should have a similar screen. Phone is the screen is too small, and so it looks different. A phone is a terrible way to do this class. For using, like, doing the homework, watching, attending class, like if you're watching the video and just taking notes, it's fine. But computers should be what you're doing homework on. You should have the same setup when you do this. I just have more practice on clicking these and what to do. If I hold down the mouse button and drag my mouse down, I can highlight all of them. If I just want to do one at a time, I can have that there and then move to the next one and hold down Control and click the next one. And then if my next value is off the screen, let go of the Control key. I'll show you what happens if you hold down the Control key in a second. But scroll down, pick your next one with the Control key, Again, holding down Control key first, then clicking it. And I can do this the whole way like that. If I try to hold down Control while what is going on there? Let go of that. Stop showing that. That's making me angry. I don't like it. It came back. Oh well, I'll get over it. If I hold down, like, let's say I want to get this Q1 again. If I hold down Control right now and use my mouse wheel and roll downward, watch what happens. Control and mouse wheel does zoom. So it's a pain in the butt. So you let go of Control, roll down to where you want, then hold down the Control. You got to hold it down. Click Q1. And do stuff that way. If you want, I can let you do it on screen and guide you through it while you're playing with it.
Okay.
Just let me know. Is there any other questions before we do that? Because if that's it, I'll just stop recording. I did this. Well, maybe not. I know I did this with Caprice last week, but I don't know if I recorded it. It might be handy to hear and see.
Because we have StatCrunch, do we need to use the formulas for standard deviation?
No. I don't want you using the formulas. I want you using StatCrunch. The formulas are even people that are super awesome at mathematics, like say me, we're human. You're gonna make errors. So, and the standard deviation, there is so many steps to make errors in it. Like doing only 5 wasn't that bad, but it was still like 20 steps. For 5 data points, there was 20 steps. For 100 data points, there's like 300 ways to screw something up. And you only got to miss one to screw it up. I want you to use StatCrunch.
Okay, thank you.
The only the section StatCrunch won't help you with is Chapter 5. A regular calculator is sufficient for that. Because we're going to be doing basic division, and doing division here, it can be done. Like I think we did 42 divided by 13. It might work here. There we go. 42 divided by 13. And I could click OK and compute. And I calculated that 3.23 earlier. But if you notice, that's a lot slower and it's not easy to remember what to do. So I recommend using a basic calculator for basic things like addition and subtraction, multiplication, and division. Anything where there's a formula, do it in StatCrunch.
Okay, thanks.
Anybody else?
I have a question.
Yes, Amanda.
I'm working on the chapter 2 homework.
Okay.
And I remember learning it, which I probably should have done the homework after learning it. For the StatCrunch, like, how do I do that for like the first question? Like, how do I set it up on StatCrunch? Of like homework?
Chapter 2?
Yeah.
Let me look at chapter 2. I don't remember what it is, so like that specific homework question.
And like how like the other girl was saying, like StatCrunch is kind of confusing. Like I don't know how you get it. Like
I've
like
been
the
teaching
number-
it for a few years. It takes time.
Yeah.
Just like
Yeah.
learning a new software program, like learning Microsoft Word or Excel, it takes a while to
Yeah.
learn it.
Yeah.
watching what I'm doing and taking notes of what I do, and I try to write it down, like the steps I do on the screen when I do it, is a way to go, because then you can look back on it later on and go, what the hell did Mr. Jones do? This is what he did. So for this one, it wants a relative frequency distribution. There's a couple ways we can do it. I'm going to do both in StatCrunch because I'm not doing any work by hand if I can avoid it. One way we could do it is you could do the graph bar plot with data. We're going to click the variable and we'll do value above bar, and I want to change type to relative frequency. So generally, the anything that says build you want to avoid. Build is bad. It's confusing even for me. The grouping thing, you can do it, but grouping is not necessary. For most things you don't want to group, you may want to set the type. My house just shook for a fraction of a second. It did not feel like an earthquake. I hope no one hit our house or something. If I click compute, it's got the values up here. How many decimal places did they want? Oh, it's already to the right number of decimal places. So it's got the values right there. Another way to do it is you can do stats, tables, frequency. Same thing, we're telling a variable where our data is. It's usually the first column. I can leave frequency and relative frequency in there. Just if they ask me both, it's already there. And it has it listed. Now I just got to match up. Thankfully, these are in the right order as this over here. So I can literally just go down the list and type. The fuck?
0.46.
Oh. Yeah, I was going through my data already. That's the first thing you do. Check to see if you made a mistake in entering the values. Okay. If it's not entering the values, make sure you don't have any spaces in there that you can't see. And then if that's not it, double check, make sure you did the right thing over here. According to the data, which blood type is the most common? It's the one that shows up the most, whichever one has the highest number. So it looks like O has the highest value. Least common would be AB. It's got the lowest value. This part uses the results of the sample to conjecture the percentage of the population that has type O. Is this an example of descriptive or inferential statistics? Whenever we are taking results from a sample and conjecturing or trying to estimate what the population is, that's called inference or inferential. So taking sample and applying it to the population is inferential. Descriptive is just doing the statistics we're doing already. These up here are descriptive statistics. Applying it to the population would be inferential. And if the sample's 46% for type O, I got to think that the population is going to be close to 46%. Oh, wait. It says percent. Percent is when we shift from decimal to percent. Actually, I'm going to do this because it's being recorded still. It's going to tell me the wrong answer. And the reason why it told me the wrong answer is I used the decimal value here. But when we shift from decimal to percentage, we have to move the decimal place to the right twice. So this would just be 46%. And then this is a question to see if you understand why the results might be different. I'll let you think about that one. Let me show you. I saw another problem in chapter 3 I kind of want to go over real quick. Where was it? Just gotta find it. It was near this one. There's this one. Here we go. So how do I do this value right here? Where's my whiteboard? So it says the median for the given set of 6 ordered data values is 27.5. So they give us, rather than using a blank piece of paper for half of a problem, they give us 7, 12, 21, blank, 41, and 50. And they say, what is the median for the given set? Or what is this value if the median, what is this value if the median is 27.5? So one way we can do this is go, okay, well, work with the median normally. I go, it's not this one. Just cross off the endpoints as I use them. I'm trying to get down to the center 1 or center 2. Center 2, it's 20. The median is the average of these two. And I don't know what this one is, but I could figure it out. Using a little bit of algebra, I have 21 plus question mark divided by 2 is 27.5. This is if you're doing the support course, there's sections on how to practice on doing this. We multiply both sides by 2. That gets rid of the 2 on the bottom here. 2 times 27.5 is 55.0 over there. And I still got 21 plus question mark. And now if I want to find out what question mark is by itself, I got to get rid of its baggage. Question mark has an extra 21 with it. I don't want the 21. I want to lose the 21. Losing the 21 means subtracting it. Whatever I do on one side, I got to do on the other. And I would get 34.0. Which will be the answer. 34 is the answer. That's the algebra way to do it. It's worth doing, making sure you know how to do it, because it is just the average of two numbers. Another way of doing it is guessing values and seeing where you get. So, like, I know it's 21 and some number. Let me guess it's 30. I'm going to make my first guess 30. 21 plus 30 is 51. 51 divided by 2 is 25.5. 25.5 is lower than what I'm looking for, so this value is not high enough. Lower means make this value go up. Let's say I make it go up to 37. So 21 plus 37 is 58. 58 divided by 2 is 29. Now 29 is higher than 27.5. I've gone too high. And so you could keep doing this until you get the right number. It could take forever doing guess and check. Doing algebra can get it to you pretty quickly. They might have one in here that does the similar with the mean. Oh God. Trimmed mean. I need to tell everybody. I need to take this question out of the data set. see if I can actually still remove it. Although people have already started, I don't know that I can. The trim mean is a pain in the butt. Skip it. It's really, it's shaving off some of the outliers to calculate a different mean. It's a pain in the butt. That's not the one I was looking for. That's a good question, though. The sum of the deviations about the mean always equals 0. You add up the plus and the minus, and they should all balance out. I was telling you guys about this. They'll give you scores and ask you to calculate the mean and standard deviation. Yeah, this is the crappy one, too. Let me make a list of questions I should go over next week on Tuesday. Just for your information, when you get to this one, what they want you to do is take the middle value. So between 10 and 20 is 15. And that's got 6 students. Between 20 and 29.9, or really between 20 and 30, is 25, and that goes with 14. And you're going to go down the list and find those middle values. And we got the numbers on the right already. I'm not changing those. To find the approximate mean right here, what you do is you multiply these together. 15 times 6 is 90. 25 times 14 is 350, I think. 35 times 26 is... Oh, God, let's see. 910? I think it's... Now I want to check. I'm doing this in my head now. Did I do this in my head right? Bam! Look at that. 910. And finally, 55 times 7 is 385. So, what we do at this point is we add up all these values. Oh, I got an error right there. Put an extra 5 in. I did not do it. All right, just clear out. 90 plus 350 plus 910 plus 855. So that's 2590 so far. And then we got to divide by the total number of students, which is this column. 6 plus 14 plus 26 plus 19 plus 7 is 72. So if I do 2590 divided by 72, I'm going to get the answer they want, 35.97. So it's not the easiest question. It's already 8:30. I'll look for the other ones later, but since I had this on the screen, it's worth answering now. You take the middle value of the cell phone plans, each row. So this is basically $10 to $20. The average, the midpoint is 15. You take that, you multiply it by the number of students, is what I did here. And then you add it up and divide by the total number of students. All right. Let's call it a wrap. If you've got more questions, bring them on Tuesday. Well, especially if you get here a few minutes early, because we can do it before class. But other than that, I will catch you guys.
Wait.
Yeah.
Do you think you could just walk me through one on chapter 2, just so I could get the stat crunch like in the columns?
Oh yeah.
Like, can I share my screen?
Yeah, share screen.
Okay.
You can share screen. Sorry, I forgot I was going to do that.
It's okay. Chapter 3. Okay, and then did you want to read it first, or did you want me to open it?
I can follow what's going on here. Go ahead.
Okay. Stat crunch. Open the stat crunch.
We just did a problem that was similar to this. So, they were asking you for relative frequency, right?
Yes.
So, oh, is this one you can do in StatCrunch? You might have to do it by hand. Do stats. Go to tables. Let's see if tables works. Frequency. Nope, it's not. You're going to have to do this by hand.
Oh, okay, so that one's by hand?
Yeah, you have to add it up. Add up the total.
Oh, sorry. I didn't even interrupt you. That, this one? Does this one work in StatCrunch?
Yeah, when it's got data values, it works in StatCrunch.
Okay, so then data?
Stats.
Or graph? Stats?
Tables.
Tables.
Frequency.
Vowels?
Yeah, that's the only, I think.
Is that it?
Something's off. Yeah, say compute. There must be more rows than I'm seeing. Yeah, okay. So it's done the relative frequencies on the right.
Oh, okay. So that's it?
That's it.
Oh, okay. I was pressing the wrong thing.
So if you go to Canvas and go to that file section, you can get a short little PDF of instructions on how to do these based on section. So if you need something to look up later on, you can always have it available.
Okay.
Another
And it was stat summary column.
Tables, stats tables.
Stats tables.
Frequency.
Stats tables. Frequency. Stats tables frequency. Got it. Stats tables frequency. All right. Thank you.
Let's see. All done. Stop recording.
Recording stopped.